Hello and welcome to In-Depth Ruby course on Eduonix. My name is Ilya and this is section 3. Probably this is the most important section of all course because Ruby is an object-oriented language. It is heavily powered by objects, and so please pay attention to the material that I'm going to present you throughout this section. So in this lecture we are going to talk about classes and methods, specifically how to define them and how to instantiate classes. Okay, so let me open my integrated editor and create a new class inside this animal.rb file. Classes are open with the class word, and then you simply type in the name of your class. That should start with a capital letter because basically class's name is a constant and constant should start with capital letters. Inside this class you can define its methods by saying def, meaning define, and then the method's name. So as for the animal, we for example can define method like, I don't know, like say. And note that the method and the class, they are closed with these AND keywords. Now let's define the method's body. Not sure yet because this is just some generic animal, so we are not sure what it is going to say yet. And next, after defining this class, this blueprint of an object, we can basically instantiate this class. That is, we can create an object of this class, the instance of this class. And so I'm going to say that the new animal, so create a local variable with such name, equals to animal, and then new. So this new, it's a special method that is going to instantiate this class. Next, having this new animal in place, I can write something like newAnimal.say to basically call this method say upon the instance of this class. So now if I run this code, I'm going to see that the animal says something. So basically that's how you can define your classes in Ruby, and we are going to see many more examples on that. And also it's worth mentioning that Ruby by default has a lot of existing classes. So for example, there is a class called array. So basically it has all the methods that are used to work with arrays. So for example, here is the method that we have used in the previous section that pushes some elements to the array, to the end of this array. And there are many other methods like slice, for example, that you can use, and many other methods. Also, of course, there are classes like fix num, for example. So this class has different methods that are used to work with basically integer numbers. And note an interesting thing here. So if you take a look to this left side of the page, you're going to see that there are methods like plus, minus, like multiply, and so and so and so. So what it means is that when we, for example, calculate the sum of two integers like this, saying 1 plus 2, basically this plus, it's not some operation, it's not some keyword of a language. Basically this plus is a method, and that's a very important concept that we should remember. Every operation that we perform in Ruby, nearly any operation in Ruby, is a method call. So even if we are performing some mathematical operations, so what it means is that this 1 plus 2 can be rewritten with a dot. So just like we do new animal say here, using this dot, we can basically say 1 and then dot plus and then 2. So this plus is simply a method's name. It's not some special construct, it's just a method's name called plus. And so basically here red 1, it's a receiver of this method, and then this green 2, it's an argument. So this whole construct means that we are calling a method called plus upon the object 1 with an argument of 2. That's how it reads. And please remember this fact. So this operation, it's a method call. And so every time you see, well, such construct with a dot, it means that you are calling some method to the right side upon the object to the left side. So basically there are no exceptions to this fact. And also you might ask why the first version works. So why can we write this construct without a dot? And basically it simply works because that's a syntactic sugar. Because we as humans, we get used to writing mathematical operations without any dots. So it's much simpler for us to just say 1 plus 2. And not do it like this, because it's well not convenient for us. And so interpreter is going to understand us. But under the hoods of this construct still means that we are calling this method upon the receiver of 1. And so 1 basically, if we type it like this, if we say 1.class, we are going to see that 1 belongs to a class of fixed num. And so here is this fixed num class that I opened a minute ago. And so here is this method. Here it is. So here is the explanation behind this method. So that's how it basically works. Also methods, of course, can accept arguments. So as with this example, basically this method called plus, it accepts one argument of 2 in this case. And in our custom methods, of course, we can make them accept arguments as well. And to do that, I'm going to place those round brackets here and call an argument, for example, word, like this. And note that right away this construct here is being highlighted with an error. So basically it says that this method called say expects one argument to be set. And if I try to run this program now, I'm basically going to see an error saying that you've called a method say, but you have not passed any arguments. And this method basically expects one argument to be set. And so to do this, I'm going to provide, for example, I don't know, test, for instance, like this. And in my IDE even highlights what argument, how this argument is called, what should be placed here. So now I can utilize this argument inside the say method and, for example, say just maybe word, something like that. Now let's call it once again, and now as you see it works correctly. If for some reason I do not wish to make this argument mandatory, so I wish to, well, provide a default value for this argument, I would say equal sign and then like any default value. It can be a string, it can be an integer, it can be an array, a hash, so anything you like. And in this case, if I do not provide basically this argument here, it will be set to this string with a value, default value. So note what happens. It says a default value now. So that's how you can set default values for your arguments. And of course you can provide many arguments at once. So let's say here word 2, word 1, like this. So the first argument is going to be mandatory, it's going to be required argument, and the second one will be optional. And I'm going to say word 1, word 2, and I'm going to say word 1 here as the first argument, and as for the second one I'm going to simply omit this argument, and now it works as well. Also note that the round brackets around arguments are not required, so you can write them or you can omit them. If you are not sure whether to place round brackets or not, it is of course better to place them just to stay on a safe side. By the way, those brackets here are not required too, but most developers tend to specify them just to quickly understand where the list of arguments begin. That's it. And also another interesting thing is that if you provide hash as the last argument, like this, so you can provide a hash. Let me rename it, like just say hash here, set it maybe to an empty hash or like this. And now if you provide the values and keys for this hash, something like that. So basically you can output this hash using inspect, so it works, of course. But what you can also do is you can also omit of those curly brackets. And this is only possible if the hash is the last argument in the list. So if the hash is the last argument listed here, the curly brackets can be omitted when calling this method. So it still works. And that's a Ruby idiom, and it is called poetry mode. So that you don't need to provide those round and curly brackets and so that your code looks less cluttered. So that's one interesting idiom that you should basically remember. Now let me bring back that word2 here, set it to default value once again, and suppose that I wish to keep the default value for the second argument, but provide my own value for this hash here. And so in order to do this, I would need to basically copy this line here and place it on the second position. Why? Well, because if I don't do this and remove this default value, note what happens. Ruby will think that this value goes to the argument with the name word2. So it will think that I am trying to set a value for this argument. So basically, it will be of course incorrect because I wish to set a value for the hash, not for the argument with the name word2. And so that's why with the following way of writing arguments, I need to basically copy and paste this default value, which is not really convenient. But luckily in newer versions of Ruby you can provide arguments in hash-like way. So how to do that? Basically you go here and simply place this colon like this, then instead of equal sign colon like this and like this. And what is going to happen is now we can provide those arguments in any order. So in basically in arbitrary order they can be provided, and this construct means that the argument named word1 is required, so it does not have a default value. But word2, it is not. It's not required, it is optional argument, and the same for the hash, it's optional argument as well. And so to provide values for those arguments, you can basically say word1 equals to this. Then this default value it can be omitted, and as for the hash, I'm going to say it like this. So now arguments are basically specified in hash style. Let's also output word2 here. And now, as you see, it works absolutely okay. So that's how you can specify arguments in hash-like way, and sometimes it can be really handy. So this ends the first lecture about classes and methods, but in the next lecture we will continue talking about them, because there are some other things I want to mention before moving to variables and inheritance in Ruby. So see you in the next lecture. Hello and welcome back to In-Depth Ruby course on Eduonix. My name is Ilya, and in this lecture we are going to continue discussing classes and methods in Ruby. So the first thing that I have not mentioned in the previous lecture is that each class can have a constructor that can be defined using a method called initialize. So basically initialize is a special method that is going to be called automatically when you say new. So right after you say new, this initialize method is called by default. So I can say creating, or just like animal is born, something like that. So now I can say ruby animal.rb, and as you see, animal is born, which is quite cool. And on top of that, I can provide any arguments to my constructor. I don't know. Provide, for example, some name. Here this name should be accepted as well. And next I can specify this name here. And now it says that animal with some name is born. So constructors are used pretty extensively, and we are going to use them as well. The next thing to mention is that methods always return some value. And note what happens if well, first of all, let me remove those arguments here. And I'm going to say simply string with a value something. So I removed this put string method, and I'm saying just something without any method calls here. Next, I'll say put string on this line 12. So I basically went ahead and removed it from here, this puts method call, and placed it here. And let's see what happens now. Let's be more explicit. I am saying something. Okay. And note that the string is still outputted to our console. And why is that? So why is this happening? Basically this happens because this line is the last line inside the body of this method. So there are no other lines in this method. And so by default Ruby is going to return the result of the last line of evaluating the code at the last line as the result of this whole method. So basically this string is being returned as a result of calling this method. And if you'd like to be more explicit, you could say return. But note that my IDE says that word is unnecessary. So this return statement is unnecessary because that's the last that's the last line of code in my method, so it is going to be returned implicitly. So in Ruby, methods always return some value. They always return something. Let me show an example of when this return keyword can be useful. So for example, let's say that this method accepts some phrase, not a word, a phrase, and by default it equals to an empty string. And here I can provide this phrase like, I don't know, test. I'm going to remove it here and then provide this phrase as using interpolation. But then I want to return from this method and well, basically return nil if this phrase is empty. So that's a small condition that returns nil if this phrase local variable consists only of spaces or if it has a length of 0. So now it says test. But look what happens if I remove this argument here and call it once again, and it returns an empty string. Let's say inspect, just to see what exactly inside the string, and it returns nil. So basically that's how you can provide such simple conditions and return nil, for instance, if the argument does not have some meaningful value. So in this case, using return is convenient. But if you simply say return like this, note that this line is now highlighted and it says unreachable code. Why? Because on line 7 we always return from this method, and so this line never gets evaluated. So never ever say return like this. Always set some condition, because otherwise it makes no sense to place any lines of code after your explicit return like this. So it makes no real sense. So that's how you can work with a return in Ruby. Now let's suppose that I wish to format this phrase somehow. So I wish to take this string that I pass as an argument, and for example I wish to uppercase it somehow or format it in any other way. For that I'm going to create a separate method and call it simply format, and then say some string like this. So that's going to be like a helper or a system maybe method for this animal class. Inside I'll say something like string.upcase. I can say return here, but it is not required because this line is the last line in this method. So this whole format method is going to return an upcased string. And let's utilize it here. You can say format and then phrase. You can also omit those round brackets here, and they are not required. So that's how you call format method with an argument of phrase. Let's check it out. And it works. The string is upcased. But the thing is that currently you can always run the following code. So you can call this format directly, and if you do this, you are going to see this test string here. But I think that this method is not meant to be called from the outside of this class, because, well, that's a system method, that's some helper method that is used only internally by other methods of this class. And to do this, you can mark this method as a private by simply saying private. And actually this private is a method itself. So it's not a keyword, it's actually a method too. So by saying private here, all other methods that follow, so all other methods that are defined beneath this word private, they cannot be run from the outside of this class anymore. So note what happens if I run the same code again. So if I try to call format method now. As you see, it says that the private method format is called for this animal object, but if I comment this line out, then all in all, everything works correctly. So this string is still upcased. So it means that the format method can only be called from the inside of this class, from other methods of this class, but not from the outside. So that's how private methods work. And now let's try to do an interesting test. I'm going to create a demonstration method here and call it, for example, with the object. And here say another object like this. Next, let's try to create another animal with some another name. It doesn't really matter. So now we have two instances of this class animal, two instances. And next let's do the following. And next let's say new animal dot with object and provide another animal. So we are passing this another animal, this object here. And remember that they are instances of the same class. And let's try to say format and then test. So what I'm trying to do is I'm trying to run this format method upon another object. but the object that is an instance of the same class. And let's check if it works or not. So I'm running this code again. And as you see, it still considers this method to be private. So you see, it still says that this format is a private method. So basically, it means that private methods cannot be called upon other objects, upon other instances of the same class. So it does not work. But what we can try to do is we can mark this method as protected, not as private. So protected method can be called in this way. So note what happens now. I'm running this method and it works. Let me output the result here. I forgot to do so. Let me output it now and it says test. So it works because I've marked this method as a protected. So protected methods can be called upon other instances of this class, like this. So it is possible. But still, if I try to do this, if I try to uncomment this line and call protected method from outside of the class, it will not work still. So you see it says protected method format. So it still cannot be called from the outside of this class. So this is a slight difference between private and protected methods, and well, please remember it as well. Note, by the way, that if you wish to set to mark some method as protected, you can also say this. You can type protected and then provide the method's name as a symbol here. And you can pass as many method names here as you'd like. So you can say with object, you can say, so on, so on, so. So you either write protected and then all the methods beneath it, or you say protected and provide methods names in the form of symbols. And also remember that by default all methods are considered to be public. So those methods, those three methods, they are public and they can be called without any problems. And the very last thing to say is that so far, well, most of our methods, they were called upon the instance of a class. But some methods are called class methods, not instance methods. And for example, this method here, this new method, it's basically a class method because it is called upon a class, not upon the instance of some class. And you can of course create your own class methods as well. And to do that, you can say class name, then dot, then the method's name. For example, I don't know, walk, because any animal can walk, basically. Something like that. And what it allows us to do is we can go ahead and let me collapse this stuff here. Basically what I can say now is I can say animal dot walk like this. So I don't have to instantiate the class to be able to run this class method walk. And note that it has to be prefixed with the class's name. And now if I run this code here, it says I'm walking. So that's how class methods are defined. And once again, this animal.new is a special case of a class method. So it cannot be run upon the instance of a class. So and the same, by the way, applies to this walk method. So I cannot do this. I cannot instantiate this new animal and then say .walk. It is not going to work because it's not you see it says undefined method for the instance of a class, because it's not an instance method, it's a class method. So please also remember this fact. We are going to work with class methods a bit more in future. So that basically wraps up this lecture about methods and classes in Ruby. And in the next lecture we are going to talk a bit more about different kinds of variables in Ruby, so well, hold on tight and see you in the next video. Hello and welcome back to In-Depth Ruby course on Eduonix. My name is Ilya, and in this lecture we are going to talk about variables. All variables that we have created up to this point were local variables. So for example, this is a local variable, this new animal is a local variable as well. That's totally fine, but the problem with local variables is that they are not visible outside of a method where they were defined and outside of a class where they were defined. So this name local variable is not visible outside of this initialize method. So I cannot say this. I cannot reference this name from outside of this method. Note what happens if I try to do this. As you see, it says undefined local variable name. So it means that, well, local variables, they are local to the method where they were defined. But it's not always convenient, because, for example, suppose I'd like each animal to have a name stored alongside, and so that later I can easily fetch this name by saying .name, for instance. So how would I accomplish this? Well, to do it I'm going to use a special kind of a variable called instance variable. Instance variable always start with an @ symbol, like this. So here I am taking a local variable and assign it to an instance variable by prefixing it with an @ symbol. And now, okay, let me remove this method, it's not really needed. Let's call this animal, I don't know, Spot, like this. Let's call it also Spot here, so I understand what is going on. And another animal called, I don't know, Buttons. It's going to be Buttons, and I'm trying to read the name of those two animals here, but unfortunately it says undefined method name. So once again we need to remember that when we write something dot and then something else, it means call a method upon some receiver. So even though we have defined this instant variable that is visible in whole class, so it is visible in each and every method of this class, we cannot simply go ahead and fetch its value like this. And to do that we need to create a special method that is called a reader, and this method has the same name as the instance variable that we wish to read. So that's a reader that returns a name of this animal. And so you either can say return or you can omit this return word, because it is this name is returned implicitly. So now that you have created this reader, you can safely go ahead and run this code, and it returns the names of our animals, and note that they do not interfere. So each animal has its own name. They do not interfere in any way. Next we can create yet another method that is called a writer. So a writer is used to obviously redefine a value of some instance variable. Writers have the same name as the instance variable, but they also have an equal sign like this, and they accept a new value. I'm going to say a new name, and that's our writer. And now let's simply say new name equals name equals to new name, like this. Let's try to redefine a name for our Spot, and note that my IDE suggests to use this name equals method. So I can of course say name like this and provide new name. It's possible and it works. but it is not really convenient to write it like this, because we as developers, we usually write expressions like this. We say name and then equal to something. So we wish to, well, assign a new value to this, well, shall we say, attribute. And this also works. So that's a syntactic sugar, and it will also work, but under the hoods it is going to reference this name equals method and set our old name with a new value that is taken, well, from here. Let's run the code again, and this new name is being displayed correctly. But as you see, after some time it becomes quite tedious to create those readers and writers, because suppose that each animal is going to have an age. By default it's going to be 0, so it's a newly born animal, so I'm going to say like 5 here, okay, as an age. And as for this age, I would have to, well, firstly I'll have to create an instance variable, but also I'll need to create readers and writers, just like for this name. And after some time my class will be bloated, because it will have many readers and many writers that basically consists of one line of code, and that's not really convenient. And thanks to dynamic nature of the Ruby language, we can create those readers and writers on the fly by using some metaprogramming. And look what I'm going to do now. I'm going to say attribute and then this accessor like this, and then say name and then say age like this. And so those methods can be commented out or they can be removed altogether. So this special method, this attribute accessor, is going to create a reader and a writer dynamically for those two attributes, for those two instance variables. So now if I run this code again, it still works. So this name can still be changed, it can still be overwritten, and it still can be fetched because of this accessor here. If you wish to define only readers, so you wish to only fetch the name but without being able to redefine it, you can say a reader here like that. But in this case, of course, it says undefined method name. So once again it proves the fact that under the hoods Ruby tries to search for a method named basically something and then equal sign. And this error happens on line 18, so it happens here because there is no writer anymore, because we set attribute reader here. If I say, of course, writer, I will be able to change those attributes, but I will not be able to read them, only write. So now it says undefined method name without equal sign, and it happens on line 19. So here. So that's how basically you can create readers and writers. I'm going to create simply accessor like this. Those methods can be removed, and now my class looks really nice. It is small, and yet I can access my attributes without any hassle. As the time goes by, of course, our animals get older, and each year I can, of course, say something like spot age equals to a spot's age plus 1. But it's quite tedious as well to always write such construct. Instead from that, I'd like to say something like spot and then get older, something like that. Let's create this method now. So this method will simply get the value of age and increment it by 1, like this. Now let's output the new age now, and it should equal to 6. That's correct, because initially the age was 5. Now we have incremented it by 1. But actually there is one convention. to name such methods. Usually methods that destructively modifies some attribute, they end with a bang symbol, with this exclamation mark. So it's not like a requirement, but that's a convention. And by the way, if we return to our methods at RubyDoc, we can search for a method called upcase. And note that there are actually two methods with the same name, upcase and then upcase, but with a bang symbol at the end. And so what's the difference between them? Well, let me open interactive Ruby shell, create a string with a test value. First I'm going to say just upcase. So, well, it did return test in uppercase format, but if I try to fetch the value of the string once again, it was not changed, so it was kept the same. And if I'd like to redefine this value, I should say the string equals to new value. So now the string has a new value, an upcased value. So that's a method's name without a bang symbol. Now let's see what happens if I define the string once again in downcase format and say upcase but with a bang symbol. So that's a dangerous method, the method that destructively modifies a receiver. So what happens now? I'm going to press enter. It returns test again, but if I say string now, you see that its value was changed under the hoods. So that's like a dangerous version of this method. So that's why this exclamation sign is added at the end of this method's name. And there are a bunch of other methods in Ruby that have both well, a simple version and a dangerous version, shall we say. And so in this case we also follow this convention, and we name our method getOlder with bang symbol to mark that this method destructively modifies an age attribute. The very last type of variables that we will cover in this course is called class variables. Class variables are defined with two symbols at the beginning and then the variable's name. For example, let's say that that's a cat, that this animal's type is a cat. Well, that's a bit contrived example, but still. So now note what happens if I try to redefine this type by using, for example, method like change type with a bang symbol. Here I'm going to say new type, then type equals to new type. And also let's get a reader for this class variable, call it just type. That is going to say the current type of an animal. I'm going to collapse this and this as well. Let's comment it here and here, and instead create two animals like that. And I'm going to say spot dot change type. And I'm going to say that's a dog, not a cat anymore. Now let's output the type for our spot. And well, obviously it should return dog now, right? Let's exit from here and run our code, and of course it says dog now because we have changed the type of our, well, of our animal named Spot. Okay, but what happens if I do the same for our buttons? I am going to say type here as well. I'm going to even say buttons type. So who is Mr. Buttons? So how do you think, what are we going to get as a result? And it appears that buttons' type is also dog now. And what it means is that class variables, they are shared between all the instances of the class. So if I change this class variable from some object, this class variable will be changed for all other instances of this class. So that's a shared variable. And actually using class variables is not really recommended because they make the code more complicated, and in many cases it's possible to solve the same task without a class variable. So that's why my IDE highlights this usage of a class variable and basically says that how about not using this variable. And so as long as this method change type modifies variable for all instances of this class, I think that this method can be defined actually as a class method, not as an instance method. So let me say animal.changeType here instead. And now to change a type for all animals, for all instances of this class animal, I'm going to just say animal and then dot change type. In my point of view, it is more correct, because this way you understand that the type will be changed globally. It will not be changed only for one animal. Let's check if it still works, and indeed it works. And that basically wraps up this video, and in the next section we are going to talk a bit more about inheritance in Ruby, so see you really soon. Hello and welcome back to In-Depth Ruby course on Eduonix. My name is Ilya and this is Lection 4, where we are going to discuss inheritance in Ruby. So let's return to our sample class called animal, and of course storing the type like this is not the best idea, because, well, usually, first of all, this type can be changed, and usually animals do not change their species, well, their type. So instead what I'd like to do is I'd like to create two more classes and call them cat and dog, like this. And obviously each animal, a cat and a dog, also have a name, they have an age, and of course I could have just copied all that code and place it here, but all in all it's not the best idea to do so, because this introduces code duplication, and later if you'd like to change something in this code here, you will also need to remember to change it here and for the dog class, and well, that's very bad idea. And there is also a principle that is called don't repeat yourself, or simply DRY. So let's not repeat ourselves, and instead let's rely on inheritance in Ruby. So basically each class in Ruby can inherit from another class, and each class can have only one direct parent. So one class cannot directly inherit from multiple classes. That is not possible in Ruby. But it can inherit from one class, and to do so I am going to say like this, angular bracket and then animal. And let's do the same for our dog class. And now let's suppose that I'm going to create like buttons once again, our favorite animal, and it's going to be a cat. And now note that even though this cat class has no constructor, it is present inside its parent class, inside the animal. And as long as cat inherits from animal, this cat gets all the methods that are defined on the animal's side, on the animal's level. So let's check it. I'm going to display the name of this animal, of this cat. Let's now run this code. And as you see, it works, even though the cat itself does not have a constructor. And also we can try to check the class of this object. It says cat, of course, but to find the parent we can say dot superclass. So basically superclass is going to output the parent, which is of course animal. So that's how you can work with inheritance in Ruby. Now you might ask what is going to happen if the parent and the child have the same method defined. Let's check it out by creating a method called say. Here I'm going to well, return a string with a value like generic same. And as for the cat, I'm going to say, of course, meow. And for the dog, I'm going to say woof. Oh, sorry. Yeah, like that. Woof. Okay, so now let's go ahead and print well, and code this same method here, and note what happens. So the cat says meow. So basically, if the child has the same method as the parent, the child's method takes precedence. So the child's method will be called as a result. But still, well, if someone inherits directly from this animal, he'll basically see this generic phrase. That's it. And what's interesting, you can even combine those two approaches by basically seeing the super word here. So super is going to say that firstly run this code here, and then please go back up the inheritance chain and call any code that is found inside the parent's method with the same name, if such a method exists. Let's demonstrate it by creating a separate method for that. I'm going to call this method walk to somewhere, for example, and create the same method for my parent. Paste this code here, and here I'm going to say parent walk into somewhere. Let's copy the string, place it here, and say child walk into somewhere, and they say super here. But note that the super now should not only call the code from the parent, but it should also pass this object as an argument, because I want to preserve this object and pass it here as well. So therefore, let's say super and provide this somewhere, like this. Okay, so now let's call this method upon our cat somewhere far away, for example. Now let's say Ruby animal, and note what happens. Now we call both the child's code and the parent's code, because we've said super here. So that's how it works, and you can always combine the child's methods and parent's methods with this approach if needed. Okay, now let me collapse these methods here, and let's try to do the following. Let's try to output all the instance methods of our cat class by saying basically instance methods. That's a special method that we basically can display all of the available methods. So I am going to call this code, and note what happens. So we are getting an array of some, well, quite strange methods that we have never defined. So here is our, for example, our say method, walk2 method, name and age. So all those methods are defined by us. But what about those methods? So where are they coming from? Because we have not defined them anywhere. Let's try to do the following. Let's try to pass false here as an argument, and as you see, this argument is called include super. So we are saying do not include methods from the parent class. Let's call this code again, and now as you see, we have only two methods, say and walk2. So those are the methods that were defined here. So yeah, here's the connection, and this way we can get only the methods specifically from this class. But this does not answer the question from where those methods came. And let's do the following. Let's say buttons.class, then superclass, and then superclass again. Because at this point we get a cat, as we already know. At this point we get animal, but what about this? So what are we going to receive now? And it appears that it says object. Okay, let's do yet another operation like this and say superclass again. So what about this level? And it says basic object. Let's try even more. Say superclass again. And at this point it basically displays nothing, which means simply nil. So what it means is that by default all our classes, they inherit from those system classes that are called object and basic object. You can find information about them at RubyDoc, so let me open this website now. So here I've entered object, let me open this page now, and to the left you are going to see all those methods that were returned for us. So here are those methods here. So here is, for example, the method called class. It's also a method, and we can find this method here. So that's why we can say buttons.class, for example, simply because it was defined upper in the inheritance chain. It was defined for this object, and there are a lot of system methods here. So there are methods like nil to check if an object is a nil. There is a method called isA to check if an object belongs to some class like this, and many different methods that can come in handy sometimes. And here is the basic object. This class was introduced in newer versions of Ruby. It was not introduced in Ruby 1.9, I think, and it has only some very generic methods. So that's like all father of all classes. So that's a top level parent of all classes by default. And it has only a bunch of really generic methods. So that's how inheritance chain work in Ruby, and basically all system classes like string, like fixnum, they also inherit from basic object and from object. So let me open my interactive Ruby shell now. I can calculate string superclass, and as you see, string also inherits from this object, so that is the default behavior for all classes. Therefore, you don't need to do anything special about it. Before wrapping up this episode, I've also wanted to cover yet another thing. So here I've created a method called info that simply returns information about the current animal. And here I say that the name is name and age is age. Okay, but those name and age, those are obviously methods because we have defined them here. Those are readers. And it appears that actually those readers can be prefixed with the following construct called self. And what it means is actually those methods are called upon the currently used object. So they are called in scope of this current object. And if I say something like buttons .info and say put string, this name will be called, of course, in scope of this buttons object. So what is going to happen is these buttons will be assigned, shall we say, to this self here and to this self here. So self is a special, like, let's say, keyword in Ruby that points to the currently used object, to the object in whose scope the method will be called. And in many cases specifying self is not really needed, and this age method will be called upon self by default. But still it worth remembering that this fact. Let's run this code, and just to make sure, and as you see it says that the name and age, they are absolutely correct. And by the way, returning to class methods, remember we created a method called change type, I'm not going to code this method now, but we've prefixed it with animal, so with the name of the class. But you can also actually say simply self. Why? Because when methods are defined, they are defined in scope of the current class, which is quite obvious. So in this case, self is going to point to animal. And so you can either say self here or you can say animal. So please remember about the self thing as well. So, well, this wraps up the current lecture, and in the following lecture we are going to talk what to do if you wish to introduce multiple inheritance. And so we are going to cover modules in Ruby, so stay tuned and see you in the next video. Hello and welcome back to In-Depth Ruby course on Eduonix. My name is Ilya and this is lecture 5, where we are going to discuss modules in Ruby. So in the previous video I've said that multiple inheritance is not supported in Ruby, and well, that's true, it is not supported, but well, what should we do if well, two different classes, let's say human and animal, sorry, it should be human, human and animal, they need to share some, well, a similar behavior, some similar methods. So of course I might have created maybe some generic class for them, but still it's not often convenient. But well, to solve this task we could have created a module. So module, well, it opens with a module keyword, and then you say module's name, something like utils maybe. And so as you see, module resembles class, and actually modules are very similar to classes, with the only difference, modules cannot be instantiated. So modules are used to firstly group some methods, some reusable code that is hooked up in different classes. So here, for example, I can define a method that will, for example, format a name, because a human can have a name and an animal can have a name, but well, apart from that, humans and animals are not, well, that similar, and there is no real reason for us to establish the common parent for them. Well, we could do that, but it's not really practical, at least not in all cases. So let's create a method inside a module and say that the name should be capital cased. Let's check the method. I think it's capitalized, sorry. So the name should be capitalized, and let's also strip out all white spaces like this. It should be stripped, so all white spaces will be stripped and the name should be capitalized. And now we can simply utilize this module, we can hook it up, we can include this module in any class we basically want. So to include a module, you say just include and then utils like this. And the same goes for the animal. And now when you do this, you can employ all the methods from this utils module quite easily. So you simply say format name and pass an argument here. Now let's display our cat's name. And now note that the name is capitalized, so the format name method was used properly. So that's how you can utilize modules, and basically any class can have as many modules included as you need. So you are not limited to including only one module, and that's how you can solve the problem of the absence of multiple inheritance. So you don't need it because you have modules, and modules are pretty flexible as well. So to summarize, including a module into your class introduces new instance methods. So when you include this utils method, you are basically defining a format name instance method, and this method can only be called upon our buttons. But there is a way to also define a class methods using modules. Let's create yet another module, and for demonstration purposes I'm going to call it animal utils. And inside, let's say, I don't know, let's say change type once again here, so that method that we have already seen. Inside I'm going to say change in type. It doesn't really matter what this method is doing. What matters is that I'm going to say extend animal utils. So I'm not saying include, I'm saying extend now. And the difference is that extending some module is going to define class methods from these modules. So it's going to take all methods from this module, incorporate it into this animal class, and all those methods they will be defined as class methods. So what it means is now you can say animal dot change type. So this change type will be defined as a class method, and it cannot be called upon buttons. It cannot be called upon instance of this class. It can be only called upon the class itself. Let's check it now. And it says changing type. But if I try to call it upon buttons like this, it says undefined method for our cat. So here it even by the way outputs attributes for this instance, but there is no such method. And actually it's not the only use case for modules. So modules, they can group some reusable code, they can be included, they can be extended, but there is another use case for modules, and this use case is namespacing. So namespacing simply means that I take some code and namespace it under some module to prevent collision of names. How it works? So here is my animal class. Let's wrap it like this, and here is my cat and my dog, and I want them to behave like one entity, shall we say, to have the same namespace. To do that, I can say module, and then, for example, I don't know, zoo. Let's say it. Let's call it like this, zoo. So I place all my classes and of course all the methods inside this module of zoo, and that's this way I namespace those classes. And what is going to happen now is that the cat cannot be instantiated this way anymore. Let's try to do it. And it says an initialized constant cat. Once again, remember that class names are constants, and it tries to search for such constant and it cannot find one. Why? Because it is namespaced under the zoo module, under the zoo namespace. To overcome this problem, you should say zoo and then like this, 2 colons. So it means like find a class called cat inside the module called zoo. And now it works. So now it says button, so it has displayed its name. And this approach is quite common. Why? Because when you are creating your third-party, well, your own library that is meant to be used as a third-party library that is going to be utilized by many other developers, so you're creating your open source library. This library, of course, has a bunch of classes, and the chances are that those classes can have the same names as the classes inside someone else's project, especially if the class has well, a common name, like like animal, or like a human, or like maybe person. So if you have such class in your library, and a person who uses this library has the same class, we introduce well, basically naming collision. And that's bad because well, the methods can clash as well, they can rewrite each other, and that's bad. And therefore, when creating third-party libraries, developers tend to namespace all their code, so all code for their library, under some module, under some name. So they namespacing it, and usually they employ some some fancy name. Usually the module, the top-level module, is called after the library's name. And let me show you a very quick example on that. Here I've opened a GitHub page with source code for the gem for the library, for the Ruby library called Koala. Koala is a special gem to work with the Facebook's API. Of course, you are not going to study the source code for this library, but what worth mentioning is here on line 6. There is a module that is named after this library, and this module is there to namespace all other code. So inside, by the way, note there is a nested module inside, and that's possible as well. But inside, on line 8, there is a class called API. But API is quite common name, and chances are that the project that utilizes this core library might have the class with the same name, and so to prevent naming collisions, the developers of this gem, they namespace it under the module called Koala. And well, I don't think there are that many projects that utilize the name Koala. So that's how namespacing works, and once again, that's very common task to do. And at the end of this section we are going to refactor our own program, the game with a pile of stones, and we will namespace all our code under our own module as well. So this wraps up this lecture, and in the following lecture we are going to talk a bit more about modules, and specifically I will going to show you how modules are used internally in Ruby. So see you in the next video, and stay tuned. Hello and welcome to In-Depth Ruby course on Eduonix. My name is Ilya, and in this lecture we are going to continue our discussion of modules, and you will learn about mixins. So let me open command line interface, my interactive Ruby shell, and let's try to compare two strings, because obviously, well, why cannot we compare two strings? Let's do it, and as you see we can do it. So A is not greater than C, well, because C follows after A in the alphabet. But, well, that's nice. Let's, however, open documentation for the string class. Here it is. But on the left side we don't see methods like less than, greater than. So as you see, there is no such methods at all. And so once again the question is, if they're not there, then who defines them? So are they defined by some top-level maybe class or some maybe included module? And actually it appears that there is a special module that is called comparable. And comparable, as well as Ruby documentation say, it's actually a mix-in. Well, mix-in is a fancy word for a module, basically. So this mix-in, or this module, is being used by many classes who can be compared, who can be ordered. And so this comparable module is, shall we say, mixed in the string class. And so that's where those methods come from. So here they are. Greater than, less than, and so on, so all those modules are there. But the question is, why do they work? They work because this comparable, it's like a contract. So when you include this comparable module into some class, it's like a contract. And comparable expects that the class has a method with this interesting name. Some people call it spaceship, well, because if you have rich imagination, this this resembles a spaceship. So this fancy module should return one of three values, either -1, 0, or 1. depending on whether the receiver is less than, equal to, or greater than the other object. So all we need to do in our class is define this spaceship method, and it should return one of those three values. And if this method is there, then the comparable module will work correctly, and we simply receive those methods like for free, and they operate correctly. And all this is possible because everything in Ruby is a method call. So those greater than and less than, they are not, well, operators, strictly speaking, they are methods. And due to Ruby's object-oriented approach to this question, shall we say, it is possible to do so. Let's see it in practice by going back to our animal class, and let's try to create yet another animal. Let's call it Spot again. And it will have an age of 3. For instance, here I'm going to say Spot. And what I want to do is I want to compare my Spot and my Spot animal and my Buttons animal. So who is bigger? But the problem is it won't work. So let's, of course, we can try to do so, but obviously it's not going to work because. And yeah, by the way, let me remove this format name because I've removed the module like this. Yeah, and it says undefined method. So yeah, it tries to run method with the name greater than upon buttons, because buttons here is obviously a receiver and Spot is an argument. But there is no such method, and Ruby does not understand what it means to compare to cats, to animals. But what we can try to do is we can go to our base class, our animal, and include or mix in our comparable module. And now remember that we need a spaceship operator defined. So let's define it here. Say other animal, because of course we should accept an argument here. And now what is left to be done is explain to this module how to compare those two animals. And it's up to us. What rule do we wish to produce here? So what does it mean one animal is greater than or one animal is less than the other? It's up to us, obviously. Well, suppose we want to compare them by their ages. So if the animal is older, then it is greater than the other animal. And it's quite easy. Let's say self, so that's the receiver of this method, dot age. And then I'm use the same spaceship method and say other animal dot age. And why it works? It works because our ages under the hoods, they are fixed num. So fixed nums, they are instances of a fixed num class. Let's go to our docs. Let's find fixed num here. And here is the spaceship operator. So numbers already have this numbers already have this spaceship operator in place. And as you see, it returns either -1, 0, or 1. Let's test it out. I'm going to say like 5, spaceship 3. And it returns 1. It returns 1 because 5 is greater than 3. If I say this, it's going to return 0. If I say like this, it returns -1 because the receiver is less than the argument. So 5 is a receiver and 100 is an argument. And so we basically rely on this knowledge. So age is fixed num, this age is obviously a fixed num as well. And so we shall we say, we are proxying this spaceship method to the method with the same name but defined inside the fixNum class. And that's it. And now when we try to compare the buttons and spot, buttons will be assigned to this self. So here we get an age of buttons which is 5, obviously. Spot is an argument and it will be assigned to this other animal. As for the spot, its age is 3. So this whole method call will return 1 as a result, because the receiver is greater than the argument. And so, having this in place, our comparable module works. So, having this spaceship operator in place, we can now compare our animals. So that's it. Let's test it out by running the code again. And it says true. It says true because buttons is greater than spot, because buttons is older. We can of course say less than, and we receive false because, well, because that's false. That's pretty much it. So that's how Mixins operate. And you can include this comparable module into any of your classes and simply define this spaceship operator. And later we will talk a bit more about Mixins, and I think we will be able to even enhance our game of stones, our game with a pile of stones, with some mix-in as well, and take advantage of some of its methods. This wraps up our discussion on modules in Ruby. Hopefully by now you feel a bit more confident about using them in practice. And in the last lecture of this section we are going to return to our game of stones. We are going to refactor it by using the techniques that I have shown you throughout this section. So see you in the next video. Hello and welcome to In-Depth Ruby course on Eduonix. My name is Ilya and this is the last lecture of section 3, where we are going to apply our knowledge in practice and refactor our game of stones. So let's proceed to the source code. Okay, so let me open this game of stones that we have written in the previous section, and currently it looks pretty ugly because everything is placed in the same file. And there are no classes, there are no methods, and so this program is hard to read and hard to change, and well, also it is hard to test. So therefore let's turn this code into, well, something more object-oriented. And first of all I'm going to create a folder called lib inside my current directory. Well, that's like a convention. So most program-specific files go to lib folder. Inside I'm going to create a file and call it simply game of stones. For now it's going to be empty. Now let's also create a directory with the same name. And basically this directory is going to host our main file that is going to be called game.rb. Inside this game.rb let's define a new module, call it, well, game of stones. And inside a class called game, it is going to have an initialize method, so our constructor, and also a method called start to, well, start our game. Now what I'm going to do is I'm going to require this file, this lib of stones game. I'm going to say require relative here. And what require relative is going to do is it will basically going to load up the code from inside this file located under this relative path. So this will be like a main file to load all our code. Let me also create some starter file that will actually run our game. It it is going to require the relative file called Game of Stones. It is going to well, define a new game like this, and also it is going to, well, basically start this game. Say new here actually. Okay, now what about other parts of our program? Basically we have at least two entities in this game. Firstly, we have a player, and basically a player can be considered like a model because it's like a blueprint of some player, and some developers tend to call it models. So let me create a models directory inside, and then player.rb file. Inside we are going to define the same game of stones module, then models, sorry, it's models, and then a class called player, like this. Inside, once again, we are going to say initialize, and probably it's going to accept a name, like this. So I'll say name, and this name will be like a reader. Create a reader for this name, and that's pretty much it. And note how my directory structure basically follows the names of my modules and players. So here is Game of Stones, here is Game of Stones, modules, and then models, and inside player, so there is a player.rb file inside, so it strictly follows my directory structure. Another entity that we have is the pile of stones. So let me create a new file here call it a pile.rb, and paste the following code inside. So once again, here we are defining the module Game of Stones, modules, then the pile class, and here are three constants that firstly say how many stones this pile initially has, and this constant is then assigned to instance variable, because later this instance variable will be changed by taking a number of stones on each turn. And note that stones is marked as attribute accessor. And also we have two constants saying maximum number of stones to take and minimum number of stones to take. So basically it means that we can take from 1 to 3 stones on each turn. Okay, so that's it for now. Let's require those relative files. Those files user require relative, and note that I firstly require those modules, and only after that I require this game, because this game relies on those two modules to operate properly. So that's why I firstly load the modules, and only after that I load the game itself, and only after that the game is actually started. Now, as for the game, what I'd like to do is I want to create some array of players, create an accessor for our players, and also I'm going to have probably a pile of stones that will be referenced just like this. So it's like models, pile .new, and that's pretty much it. Here I'm going to say that this pile is a reader, and now we need to understand how exactly are we going to initialize our players. And yeah, you know what, I think players is a reader, should be defined as a reader as well, because we won't change players throughout this game. So it will be defined only once. So let's define a new method called something like initialize players. This is going to be a private method, and inside I'm going to say that this should be done 2 times, and I'm going to say map here. Inside, let me place basically the following code copy it from here, from the previous version, paste it here, and instead of saying just gets and then dot strip, I am going to say game of stones, then models player.new, and then provide the user's input as an argument. So that's so this user input is going to act like a name for this player. And what is going to happen is this code is going to create an array of 2 elements, basically. Let's check it really quick by saying irb times map, then say something like just I. And as you see, it returns an array of 2 elements. So this map method, we have already discussed it. It takes some array, transforms it somehow, so replaces old elements with new ones, and basically returns the result. So this whole method is going to return an array of 2 elements, and each element will look like player.new with some name. So that's the idea of how exactly this works. And therefore our player's instance variable is going to contain an array of players. Great. Now also let's display welcoming message. I'm not sure if it's really required, but well, for the sake of demonstration, let's display this this message as well by saying simply welcome. Okay. So our players is an array, so we can cycle over them just like we did in the previous version of our program. But now on each iteration I'm going to say that player and then make your turn, something like that, make turn. And we are going to pass this pile object as an argument here. So here player is going to enter how many stones he wishes to take, basically. So let's define this method for the player class. Define it here, say that this is a pile from which we are going to take a number of stones. For now, let me simply copy this line of code here and modify it as needed. Okay, so I think that here we can say pile.stones to say how many stones are there in this pile, because stones is an attribute accessor, therefore we can output it. And then we can define the player's name. So we can either say name or we can say self, and in this case self points to the current player. So it points to the player in whose context was this method called. So it points to this player. Basically that's the meaning of self in this case. And now we need to take a number of stones, basically. To do that, I will simply say take stones from and then pass this pile as an argument. So that's a new method that we need to define. It's going to be a private method. It is not going to be called from the outside of this class. The pile should be present here as well. And just cut this code from here and place it here. Okay, but that's not enough as well. So first of all, I don't like this number equals to 0. It's not looking really great. Let's instead assign this number with a loop, with this endless loop. Inside this loop, we are getting user's input, convert the number to an integer, check if this number is valid. By the way, here it should say pile.stones for now. And then we break from this cycle. But what I want to do is I want to break from the cycle and also return a result a final result of this cycle. And the final result is going to be this number. So I'm going to say break and then number. And what is going to happen is as soon as we break from this loop, this number will be effectively returned as a result of this whole loop. And so this local variable number is going to contain the entered number, the correct number entered by the user. So that's the whole idea behind this code. But I think that also we can say that if pile has enough stones like this, so we basically delegate this task of checking if the number is correct or not to our pile, because it's the pile's responsibility to check if we can take something from it or not. So that's the idea. So let's go to our pile and say has enough stones. This question mark says that the method returns a Boolean value, so it can be used easily inside the condition. Now let's say that if number is between minimum and maximum, and number is less than the number of stones, you can say self, you can omit self, it's up to you, then we have enough stones to take. Great, and lastly let's simply say pile and then take number. Well, now let's define this method, pass the number here, and simply say stones equals to stones minus this number. Well, we can check just to be on a safe side if the number of stones is enough. Let's do it, but it's not really required, but let's do it here. So that's it. That's our players class that can make a turn and can take stones from some pile. That's pretty much it. And the last thing here to do is to check if a player has lost or won. And so a player has lost if he has taken the last stone in the pile. So let's ask if the pile is empty, then this player basically lost. And we break from this cycle. So as for the empty method, it's quite simple. We basically ask if the number of stones is 0 or not. What about the lost method? We basically say that player name lost. One last thing to do is remove this players variable, because we simply want to map and return an array of players, so we don't need to push anything anywhere. And now let's clear the screen, run our starter. I'm going to say in JNet Jack, and I'm going to just take 3 stones, take 3, take 2. Now I can say like 3, but it says please enter the correct number, because the number of stones is 2. So I'm going to take only 1 stone, and then basically Jane can only take 1 stone. So Jane basically lost, and the game ends. So this ends this video on refactoring our game. We will revisit it in the upcoming episodes. For now, stay tuned and see you in the next section.